Hello dear students, I am Ronak Kumar, your physics faculty at Aakash, and a very warm welcome into this session in which we are going to discuss the problems that appeared in the paper AIATS plus phase 2 mock test 2 that was conducted on 26th of January 2025. And I will be dealing with the problems. Let me select the pen first. So I will be dealing with the problems that are based on the chapters current electricity, motion in a straight line, kinetic theory, thermodynamics, alternating current, and electromagnetic waves, right? Now, dear students, let's move towards our first problem, which says that, here is the first problem right in front of your screen, which says that a transformer has 1000 turns and 1000 turns in primary coil and 1500 turns in secondary coil. If AC voltage in primary coil is 200 volt, then the voltage in secondary coil is what you are required to find. Now, such kind of problem was there in the mock test 1 also that we just discussed, right? So let us go through the concepts first. So what do we need to learn to solve such kind of problems? These are the basic problems based on the chapter of transformer. So a basic concept is that Vs, it denotes the voltage across the secondary. So Vs by Vp. What is Vp? It is the voltage across the primary. So Vs by Vp, it will be equal to Ns by Np. What is Ns? Number of turns in the secondary, and what is Np? Number of turns in the primary, right? So Vs by Vp, it is equal to Ns by Np. This is one of the relation that you need to keep in mind while dealing with the problems of transformer. Now, dear students, this relation is self-sufficient to solve this problem, but what other concepts are involved in while dealing with the problems of transformer? Let us discuss those two. So, other than this, if you want to write the input power, how do you write the input power? Input power can be written as the product of input current into the input voltage, and going with the similar logic, output power, P output, it can be written as Vs into Is. So input power is IPVP, output power is VSIS. What is IP and what is IS? So IP is your primary current and IS is your secondary current, right? And how do we define the efficiency? Efficiency is defined as the output power upon the input power, right? Efficiency, that's how you define the efficiency, input power by the output power. So these are some of the key concepts that you need to keep in mind, to solve the problems of transformer. Now let's head back to the original problem. It says that transformer has 1000 turns in the primary coil. So I'll put NP to be equal to 1000, and it has 1500 turns in the secondary coil. So I'll put Ns to be equal to 1500. Now if AC voltage in primary coil is 200 volts. So AC voltage in primary coil is 200 volts. So Vp, it becomes 200. AC voltage. Then we need to find Vs. Okay. That is the data given to you in the problem, and you need to find the Vs. Very simple. You just use the relation Vs by Vp. It should be equal to Ns over Np. Now, what is Vs? Vs is what we are required to find. What about Vp? Vp is given to you as 200, and number of turns in secondary is 1500, and number of turns in primary is 1000. Cancel the zeros, 5352. So from here, if I write Vs should be equal to 300 volts. 300 volts is the correct answer to this problem, which is given to me in option 3, right? So the correct answer to this problem is option 3. I hope this problem is very clear to you, and let me give you some more concepts. Okay, let us deal with some more concepts. Okay, what if Vs is greater than Vp? Such kind of, if the secondary voltage is greater than the primary voltage, such kind of transformer is called step up. And if I reverse this, if Vs is less than Vp, in that case the transformer will be called as step down, right? Now if Vs is greater than Vp, it means that NS should be greater than NP. And if Vs is less than Vp, like in this case, it means that Ns should be less than Np, which means Ns should be less than Np. So that's how you define step up and step down transformer. Now, dear students, let's have a look at this additional problem. If you are clear with the concepts of transformer, attempt this problem and put your answer in the comment box. Up till then, I'll go through the problem for you. It says that a power transmission line feeds input power at 2300 volt. So input power at 2300 volt to a step down transformer. So the transformer is step down with its primary winding having 4000 turns. So the primary winding is having 4000 turns, giving the output power at 230 volt. If the current in the primary of transformer is 5 ampere and its efficiency is 90%, then you need to find the output current. Now this problem tests all the concept that we just discussed for the previous problem, right? So let me put the data in the problem. It says that it feeds input power at 2300 volt. So I'll write Vp to be equal to 2300 volt, right? If someone has got the answer, put your answer in the comment box. So Vp is 2300 volt. It is a step down transformer. Since it is a step down transformer, I can conclude that Vs should be less than Vp or Ns should be less than Np. Now, with its primary winding having 4000 turns, so Np is 4000. Output power at 230 volts, so Vs is 230. And it was very evident also that since it is a step down transformer, Vs will be less than Vp. So Vs is 230 volt. Now in the current in the primary of transformer, so IP is also given to you as 5 ampere. Then what do we need to find? We need to find the output current. Output current means the secondary current. Is is what we are required to find. So dear students, we can use the relation of efficiency. What is efficiency of a transformer? It is defined as the ratio of output power upon the input power. Now, according to the problem, the efficiency of the transformer is 90%. So I can write that 90 by 100, it is equal to output power. Output power, let me write the expression for the output power. It is Is Vs. And what about the input power? It is Ip Vp. So I can write that 9 by 10. 9 by 10, it is equal to Is Vs upon Ip Vp. Now we just need to put the data. So Is is what we are required to find. Ip is 5 ampere. Np is Vs is 230 volt and Vp is 2300 volt. So I can put the data 9 by 10. It is equal to Is is what I am required to find. And Vs is 230. Ip is 5 ampere, I guess. Yes, 5, and Vp is 2300. So let me cancel this. So 110 over here. So it becomes, Is becomes 9 by 10 into 50, which is coming out to be equal to 45 amperes. That means that the output current would be equal to 45 ampere. Okay, someone commented the answer, it is 45 ampere. Yes, very good. The correct answer is 45 ampere and very few students got the right answer. Okay, someone is commenting answer, yes, it is 45, yes. So if you are thorough with this problem, then you are good to go with all the problems that would be appearing in the upcoming NEET examination. This problem is test your concepts, all the concepts that were discussed while dealing with the transformers. I hope this concept is clear to you. Now let's move to the next problem, and it is a problem based on the chapter of current electricity, and it was problem 23 in the original paper. It says that the effective resistance between the points A and B is. So you need to find the effective resistance between the point A and the point B. Now what tools do you need to solve such kind of problems? First is that, okay, first thing first, R equivalent. So you should be very thorough with the formula for the R equivalent for the series and for the parallel combination. So R equivalent for the series combination, it is very simple, R1 plus R2 and so on, right? And R equivalent for the parallel combination. So I'll write in a different manner. So R 1 over R equivalent, it is equal to 1 over R1 plus 1 over R2 and so on, right? And what other concepts are involved for the series and parallel combination? You should be thorough with the concept that in the parallel combination, the potential difference is going to remain same, while for the series combination, the current is going to remain same. These are the basic concepts that you need to keep in mind while dealing with the problems of problems of finding the effective resistance. Now, let's head back to the problem. So we need to find the effective resistance between the point A. There is your point A and this is your point B. So we need to find the effective resistance between the point A and the point B. So if I try to draw this in a different manner, this is my point A, and I have one branch which says that this is one of the branch, and this is my point B. So I have 2 ohm and 2 ohm over here. In the next branch, I have 3 ohm over here, and in the very next branch, I have 1 ohm and 1 ohm over here. This is also 1 ohm, this is also 1 ohm. So 2 ohm, 2 ohm, 3 ohm, 1 ohm, and 1 ohm. Now, if you look at this circuit, it is very much simple to analyze that these 2 ohm, 2 ohm, they are in series combination. This 1 ohm and 1 ohm, they are in series combination. So if I try to draw the equivalent circuit, I'll draw it as this is my point A. This 2 ohm and 2 ohm, the equivalent for this series will be 4 ohm. So I'll write 4 ohm over here. This is 3 ohm. I'll represent it like this only. So this is 3 ohm. And what about this? 1 ohm and 1 ohm. 1 ohm and 1 ohm, it becomes 2 ohm. So it comes like this. So 4 ohm, 3 ohm, 2 ohm. That's your point A and that's your point B. I hope this is very much clear to you. Now, all these three, they are in parallel combination, right? So if they are in parallel combination, you can use the formula 1 over R equivalent. It should be equal to 1 over 4 plus 1 over 3 plus 1 over 2. Now you just need to solve this. Take the LCM. It should be 12. So 3 plus 3, 4 plus 2, 6. 3, 4, 7 plus 6, 13. So 1 over R equivalent. Okay, so let me solve it over here. So 1 over R equivalent, as you can see, it is coming out to be equal to 13 by 12, or R equivalent will be equal to 12 by 13 ohm. R equivalent is coming out to be equal to 12 by 13 ohm. And which option is correct? Option 4 should be the correct answer to this problem. I hope this problem is clear to you. It was an easy problem, right? Not a very difficult problem, I'll tell it to be. So it's a very simple problem based on the series and the parallel combination. Now, if you are clear with this problem, let's head back to the next problem. Let's move forward to the next problem. And there you go. It is a problem based on the chapter of electromagnetic waves, and this is problem 25 of the original paper. It says that you need to find the phase difference between the electric field and magnetic field in a traveling electromagnetic wave. So you need to find the phase difference between the electric field and the magnetic field in a traveling electromagnetic wave. Now, dear students, many of you must be confused between two options. One is 0, second is I guess pi by 2. So most of the students, they are confused that whether the phase difference should be 0 or whether the phase difference should be pi by 2. If I'm clear in my head, then pi by 4 and pi would be the least option that you are going to take. And these 1 and 3 are the most probable options that you are going to pick. And I am very much confident that most of you must have done wrong by picking the option 3, that is pi by 2. Now dear students, please be very thorough with the concept that the phase difference between the magnetic field and the electric field in a traveling electromagnetic wave is equal to 0. There is no phase difference between the electric field and the magnetic field in a traveling electromagnetic wave. However, they are both the electric field and the magnetic field, they are perpendicular to each other, and they are also perpendicular to the direction of propagation of wave. So that pi by 2 term, it comes when you are asked that whether they are perpendicular to each other or not. Yes, they are perpendicular to each other, and they are perpendicular to the direction of propagation also. But the phase difference between them is equal to 0 because both of them will attain the maxima at the same time, both of them will attain the minima at the same time. So yes, the phase difference between the electric field and the magnetic field in a traveling electromagnetic wave is 0. I hope this concept is clear to you, and if again this problem comes right in front of you, just take the answer to be equal to 0. So option 1 is the correct answer to this problem, right? So option 2, it is a absolutely wrong option. Option 3, you must be confused in this, and option 4 is definitely wrong. So phase difference is 0, and you must be very clear with the concept. Now let's head back, let's move forward to the next problem. Okay, there you go. It was problem 10 of the original paper based on the chapter of thermodynamics. And it says that an ideal gas goes from A to B, and you have been shown A and B in the diagram. Have a look at the diagram. So an ideal gas, it goes from A to B via two processes, 1 and 2, as shown in pressure volume graph. So you have been given the PV curve, 2 points A and B. If W1 and W2 are the work done by the gas in the process 1 and 2 respectively, then you need to compare the work done by the gas in the process 1 and 2, W1 and W2. So you just need to compare, and if I go with the comparison, you just need to comment whether the work done will be positive or negative. They are not even asking about the magnitude part. They're just asking that whether the okay, someone is asking 45 question honge ya 50 question. Obviously the number of problems will be 45 only. So let's get back to the problem. So we just need to comment whether the work done will be positive or the negative, right? So dear students, let's solve this. So it is very much, what are the concepts that we need to keep in mind while dealing with such problems? So work done, if this is your PV curve, I'm drawing a random PV curve. If this is your PV curve, then the work done is given by the area under the pressure volume curve projected on the volume axis. This area is going to give you the work done. This area is going to give you the work done. And if I talk about the magnitude, so if the volume is increasing, then it is a case of expansion, and which means that work is done by the system, or in a simple manner, work done is positive. If the volume is increasing, and if the volume is decreasing, in that case, work done will be negative. So work is done on the system. So you just need to keep in mind that if work is done by the system, that means that the volume of the system is increasing. In that case, work done will be positive. If the work is done on the system, the volume will be decreasing. That means the work done is negative, right? If you are clear with this problem, let's see. So you need to compare, okay, just have a look at the process 1. And I'm very much clear that in the process 1, the volume is increasing. So for the process 1, if the volume is increasing, that means that this work done will be greater than 0, right? Okay, someone is commenting, dono hi positive lag raha hai. Okay. And what about work done in process 2? Work done in process 2. Again, the volume is increasing, so work done in process 2 is also greater than 0. It's a simple problem. You just need to comment whether the work done is positive or the negative. So both the work done are positive. Now my question to you is that which one is greater, the work done in process 1 or the work done in the process 2? Just comment your answer in the comment box that which one is greater, W1 or W2. Till then I'll find the right answer for you. So this one is wrong, this one is also wrong, this one is right, and this one is also wrong. So please put down the answer in the comment box that which one is greater, work done in process 1 or the work done in the process 2. Anyone can comment the answer in the comment box. I'm waiting for your answer. Third, I'm not talking about this problem. I'm asking whether the work done will be positive, or which one is greater, work done in process 1 or work done in process 2. I'm asking you to compare the magnitude of both these. 1, okay, yes. And how do you determine it? So it is a very simple, I'll have to erase it first. Oh, let me draw it over. So this is process 1, and if I try to get the area If I try to get the area, area will be something like this. So this whole area will be covered under the process 1. And if I talk about the process 2, so this is process 2. So this blue area will give me the work done in process 2. So obviously work done in process 1 is greater than work done in process 2. So work done in process 1 is greater than work done in process 2. It is a fairly simple problem. Can anyone give me what should be the change in internal energy for the process 1 and process 2? If I compare delta U1 and delta U2, so which one should be greater? Delta U1 and delta U2. If I talk about the delta U1 and delta U2, which one should be greater? Anyone? So it is a simple thing that if I try to put it like this, if you need to compare the delta U, you need to keep few things in mind. So see, delta W or the work interaction or the work done, it is a path function. Delta U, delta W is a path function. Delta U is a point function. Delta U is a point function. And let's talk about delta Q, heat interaction. It is also a path function. So while I was talking about the process 1 and 2, you can see that delta U is a point function. If delta U is a point function, then the initial and the final state are same, both for the process 1 as well as for the process 2. So if the initial and the final points are same, so delta U1 will be equal to delta U2. That is what I was asking to you. Delta U1 will be equal to delta U2. So these are the key concepts that you need to keep in mind while solving such problems. Now, if you are clear with the concept, attempt this problem. It says that following figure shows two processes A and B for a gas. If delta QA and delta QB are the amount of heat absorbed by the system in two cases, so delta QA and delta QB are the heat absorbed by the system in the two cases, and delta UA and delta UB are the changes in the internal energy respectively then. So you need to compare delta QA and delta QB. Also you need to compare delta UA and delta UB. So you need to compare these. Delta QA and delta QB, delta UA and delta UB. And you have been given a PV curve. You have been shown the initial state by point I, and you have been shown the final state by point F, right? So let's first talk about delta UA and delta UB. So delta UA and delta UB, we just discussed that delta U is a point function. So initial and final state are same, which means that delta UA will be equal to delta UB. Right? Delta UA should be equal to delta UB. 3333. Okay. What is 3333? Okay. Now let's talk about delta QA. So dear students, I know that from first law of thermodynamics that delta Q, it is equal to delta U plus delta W. Right? Now delta U is same. Delta U is same for both the processes A and B. So I can write that delta QA will be equal to delta UA plus delta WA. And delta QB will be equal to delta UB plus delta WB. Right? So delta U is same. So if I can say that if I compare delta W, if delta WA comes out to be greater than delta WB, if work done in process A is more than the work done in the process B, which it means that delta QA should be greater than delta QB. It is very much obvious that if the work done is more for the process, then heat absorbed will be more, right? So if the work done is more for the process A, that means that more heat will be absorbed because the portion of heat that is utilized for the change in the internal energy, it is same for both the processes A and B. So rest amount of heat will be utilized for the work done. And work done, if you see from the PV curve, work done is more for the process A, because the area covered for the process A will be more as compared to the area covered for the process B. If I draw the area, this will be the area covered for the process B, right? And this whole area, so area is covered more for process A, so work done in A is greater than work done in B, which means that delta QA should be greater than delta QB. So if I go with the answer, delta QA should be less than delta QB, wrong. Delta QA should be greater than delta QB, but it says that delta U, so it is also wrong because it is showing greater. Let's talk about third option. Delta QA is greater than delta QB, delta UA is equal to delta UV. This one seems correct. Option 3 is the correct answer to this problem. I hope this problem is clear to you, and this is one of the good problems that can be asked in the NEET examinations. I hope you are clear with the concepts. Now let's move forward to another problem, and it is a problem based on the chapter of motion in straight line. In the original paper, it was problem 7. It says that, let me read the problem for you. It says that velocity time graph of a particle is shown to you. So VT graph of a particle is shown to you. Correct? Acceleration time graph of the particle is what you are required to find. So you need to find the acceleration time curve. Dear students, what does the slope of VT curve represents? The slope of VT graph. Slope of VT graph, it gives you acceleration. Right? I hope you are clear with this. Slope of VT graph gives you the acceleration, or I can write that A is equal to acceleration, it is equal to dV by dt. Right? So if velocity is a function of time, then you can get the acceleration by doing the integration, that is dV by dt. Right? Now let's head back to the problem. It says that you need to find the acceleration time curve. Now I can see that the variation of velocity with the time is straight line, which means that the slope is going to remain constant. So the first point of conclusion by looking at the curve, I can say that the slope is going to remain constant. If the slope is going to remain constant, it means that the acceleration is going to remain constant. So the first point of conclusion is that acceleration is going to remain constant. And if I look at the options, acceleration is going to remain constant. That means that this one is wrong. This one is also wrong, because in both of these, acceleration is varying. So acceleration needs to remain constant. Now let's head back to the second piece of information. As you can see that the slope over here is negative. So the slope of VT curve is negative as well as constant. So the acceleration will be negative and constant. So going by the logic, the acceleration time curve should look like this. If this is time and this is acceleration, then it should look something like this. It is negative and constant. Let me put out the value for you. So value will be, if this is 10, so this tan theta, it will be equal to, this tan theta, if I calculate for you, it is 20 by 10 or 2. So acceleration will be equal to minus 2 meter per second square. So this will be minus 2 meter per second square. And this should be the correct variation for the acceleration time curve. And it is given to me in option 1. So this one is the correct answer. Option 1 should be the correct answer. If you are not clear with the concept of slope, you can also go by the you can also form the equation, then you can get to the answer. If I try to form out the equation for this, see, if I try to form out the equation, let me rub something. I'll rub this. If I rub this, you see, I can say that velocity and time, they have a straight line variation. So the equation should be something like this. V should be equal to kT plus constant. This should be the format of the equation. V should be equal to kT plus constant. Now dear students, at t equal to 0, V is equal to 20 meter per second. So if I put this, it should be equal to 20 K into 0 plus C. So the value of C is coming out to be equal to 20. So first piece, from the first piece of information, V is coming out to be equal to KT plus 20. Now, at t equal to 20, velocity is minus 20, right? So I can write that minus 20, it is equal to K into 20 plus 20. So from here I can write that 20K, it is equal to minus 40, or I can write that K should be equal to minus 2. So if I form the equation is coming out to be equal to minus 2t plus 20. There you go, you have an equation of velocity and time, that is minus 2t plus 20. You need to find the acceleration. Acceleration will be equal to dv by dt. Integrate this, it will be equal to minus 2. So acceleration is minus 2, negative and constant. That is the information we derived from the slope also. So obviously, the correct answer to this problem will be option 1. This is one of the approach, but it is a bit time taking. So you need to form the equation, then you need to differentiate it. But I'll say go with the slope logic. It will give you the quick answer, and you will save your time in the examination. So I hope this problem is clear to you. Let's head back. Let's move forward to the next problem of this discussion. Okay, there you go. You have this problem 13 of the original paper. It says that the number of degrees of freedom of He gas atom is. So you need to comment about the degree of freedom of a He gas atom. Now, what kind of a gas is He? It is monatomic, diatomic, or triatomic? Anyone comment it in the comment box? Put it in the comment box that what kind of a gas is He? Monatomic, diatomic, or triatomic? Anyone? Okay, He. Let's first talk about degree of freedom. So we are talking about the degree of freedom. Let's have a quick discussion about degree of freedom. So dear students, we have three kind of gases with us. One is monatomic. One is diatomic, and one is triatomic. And in triatomic, we have further two parts. One is linear and another one is non-linear. Right? And we are ignoring the fact that we are ignoring all the degree of vibrations that are included with the degree of freedom that are included with the vibration. So we are ignoring the vibrational degree of freedom. Let's talk about only the rotational and the translational part. So if I talk about the monatomic gas, it will have 3 translational degree of freedom, right? Which means that the degree of freedom for it should be equal to 3. So F should be equal to 3. And if you want to write CV, it will be equal to FR by 2. The formula for CV, specific heat at constant volume, is CV. That is equal to FR by 2. So it will be equal to 3R by 2. Right? Let's talk about the diatomic gas. So it will have 3 translational degree of freedom, just like monatomic, plus 2 rotational degree of freedom. So the total degree of freedom becomes 5. So the value of CV will be equal to 5R by 2. Right? Let's talk about the linear triatomic. So it will have 3 translational degree of freedom, plus now it will not have 2 degree of freedom associated with rotation. It will have only 2 degree of freedom associated with rotation. So the total number of degree of freedom for linear triatomic is 5, which means that the value of CV again becomes 5R by 2. What about the non-linear triatomic? Non-linear triatomic, 3 translation plus 3 rotation, total degree of freedom becomes 6. That means that the value of CV, it becomes 6R by 2, that is equal to 3R. Now, if you are clear with this chart, you can find out CP, CV, gamma. You can calculate everything if you are clear with this chart. So let's head back to the problem. So He, all of you have commented that He is a monatomic gas, which means that it will only have 3 translational degree of freedom, right? 3 translational degree of freedom, which means that the correct answer should be option 4, that is 3, right? And if they asked you about any other gas, you can just learn this chart, and there's not even a need of learning this chart. If you're thorough with the concepts of degree of freedom, you can easily calculate which gas will have how many degree of freedom, and obviously we have ignored the vibrational degree of freedom altogether, right? So I hope this concept is clear to you. Now let's move back. Now let's move forward to the next problem. There you go. This was the problem 48 of the original paper. It says that the temperature of n moles of an ideal gas is increased from T0 to T0. So it is increased from T0 to T2 to T0 through a process P is equal to alpha T. So the process equation is given to you. P is equal to alpha T, right? Now, dear students, if I try to conclude something from this part, I can say that if P is equal to alpha T, that means that the pressure is proportional. So I'll write it, I'll not write this much. So I can write that pressure is proportional to temperature. That is a piece of information I can derive from the process equation, that pressure is proportional to temperature, right? Now, if pressure is proportional to temperature, I can say that from ideal gas equation, PV is equal to nRT. PV is equal to nRT, and pressure is proportional to temperature. It means that volume is constant. So from the process equation, if pressure is proportional to temperature, I use the concept that, okay, someone is commenting me the answer nRT0. Okay. See, pressure is proportional to temperature. From ideal gas equation, PV is equal to nRT. If pressure is proportional to temperature, volume should remain constant. If volume is constant, then what should be the work done? If volume is constant, then the work done will be equal to 0. So work done will be equal to 0. If this is the process equation in which pressure is proportional to temperature, the work done will be 0 because volume is going to remain constant. So the correct answer to this problem should be equal to 0. Option 2 is the correct answer to this problem. So nRT0, I hope nRT0 is not the right answer to this problem, but I can give you a different problem in which you can get this answer. Attempt this problem. So there you go, you have a problem right in front of you. It says that the temperature of n moles of an ideal gas is increased from T0 to T0. Now I have changed the process equation. This time the process equation is V is equal to alpha T. So the work done by the gas is given by, so you need to calculate the work done by the gas. V is equal to alpha T is the process equation. Anyone can put the answer in the comment box. If V is equal to alpha T, from ideal gas equation, I know that PV is equal to nRT. PV, it is equal to nRT, right? PV is equal to nRT and volume is proportional to temperature, right? Anyone just put the answer in the comment box. If you are clear with the concept, you can solve this problem. If volume is proportional to temperature, I can say that pressure is going to remain constant. And what do we call the process in which process is going to remain constant? Anyone? What do we call the process in which the pressure is going to remain constant? What is the name of that process? Anyone can comment the name of the process. It is isobaric process. So we have isobaric process. Now, dear students, what is the work done? What is the formula for the work done in the isobaric process? So, dear students, work done for the isobaric process is what we are required to find, right? Work done for the isobaric process. Okay, yes. So, dear students, I can say that dW, or a very small work done, displacement work done, it is defined as PdV. Right? Now, if the pressure is going to remain constant, so delta W, if we integrate this, it becomes equal to P delta V. Right? So delta W is P delta V. So delta W is P delta V will be equal to V final minus V initial. Right? So delta W, if I try to modify this, if I take this P inside, it will be equal to P final V final minus P initial V initial. P final V final minus P initial V initial, and P final, it is equal to P initial because it is an isobaric process. From ideal gas equation we know that PV, it is equal to nRT. So delta W, it is equal to P final V final minus P initial V initial. It will be equal to nR T final minus T initial. So there you go. You have two different formulas. These are the three formulas that you need to keep in mind with a slight variation for the work done in the isobaric process. V final minus V initial, P final, V final minus P. So these are the three formulas that you need to keep in mind while dealing with the problem. Now let's head back to the problem. So what is the problem? You need to calculate the work done for this process. This is an isobaric process. Now you're thorough with the concept. Just give me the answer to this problem. What should be the answer to this problem? It is an isobaric process. The formulas are right in front of you. Just solve the problem and give me the answer to this problem. Anyone? Okay, no answer in the comment box till now. I'm counting. It's a simple problem now. You just got to know what kind of process you are dealing with. Now you just need to pick the correct answer. And for your hint, you can use this formula delta W, it is equal to nR delta T. You just need to use this formula delta W, it is equal to nR delta T, and you just need, okay, someone has commented the answer. So delta W, it is equal to nR delta T. What is the value of nR delta T? N is N, R is R, number of moles. What is delta T? So final temperature is 2T naught and initial temperature is T naught. So 2T naught minus T naught. So it becomes nR T naught. So delta W is coming out to be equal to nR T naught. So you can see that by just by, okay, someone is commenting answer alpha. How do you get to the answer alpha, not alpha? How is alpha coming in your answer? No, not 4 option. Option 3 should be the correct answer. How are you guys getting the option 4 as the correct answer? Option 3 is the correct answer. Correct answer is nRT naught. You just need to use this formula nR delta T. So in the original problem that was asked to you in the paper, you can see that one of the options says that the work done should be equal to nRT naught. So nRT naught, it can be the answer if we change the process, and the process should be V is equal to alpha T. That is isobaric process. Yes, the correct answer should be option 3. Now many students are commenting the answer is option 3. Correct answer should be option 3 only. How are you getting this option 4 as the answer? So this one is wrong, this one is also wrong. Correct answer is option 3. Right? Now dear students, let's move forward to another problem. Okay. So this time we have internal energy. I hope that problem was clear to you. Okay. Now dear students, we have in front of you internal energy. So we need to comment about the internal energy. Internal energy of an ideal gas changes with change in its. So we are talking about the internal energy of an ideal gas, and it changes with change in its. Okay, so let's go through the options. It says that pressure only, volume only, temperature and pressure. So dear students, anyone can guess the answer, or can you comment the answer to this problem? Anyone can comment the answer to this problem? The internal energy of an ideal gas changes with change in its. See dear students, I know that the internal energy of an ideal gas is the function of temperature only. temperature. So internal energy of an ideal gas is the function of temperature only. This part we learned from the thermodynamics as well as from the kinetic theory of gases. Both of these chapters, they were very much emphasizing on the fact that the internal energy of an ideal gas is a function of temperature only, and I can even prove that to you. See, we have four kind of processes with us: isobaric, isochoric, adiabatic, and we have isothermal. Now, if I ask you to calculate the change in internal energy for all these processes, so for the isothermal process, you will comment that delta U should be equal to 0, because in the isothermal process, there is no change in the temperature, so delta U is going to be equal to 0. Now, what about all these three processes? For all these three processes, we use the equation delta U to be equal to NCV delta T. For all the three processes, either whether it is isochoric, isobaric or adiabatic, delta U it is equal to NCV delta T, and for the isothermal part, delta U is equal to 0. So obviously from the point of view of thermodynamics, the change in the internal energy, it is the function of temperature only. And what do we learn from the chapter of kinetic theory of gases? It says that, see, delta U, how do we write the expression for the delta U while dealing with the chapter of kinetic theory of gases? So it is equal to the number of moles into the degree of freedom, F into 1 by 2 RT. So delta U is equal to N into F into 1 by 2 RT. So that is the expression that you get from the chapter of kinetic theory of gases, and this is what you get from the chapter of thermodynamics. So either you go with the thermodynamics, either you go with the kinetic theory of gases. The correct answer to this problem, so internal energy of an ideal gas changes with change in its temperature only. So option 3 should be the correct answer to this problem. Right? Someone is commenting the answer is option 4. Why are you commenting the answer is temperature and pressure? Adiabatic U equal to W, isochoric NCV delta T. So someone is commenting the expression for, okay, adiabatic U is equal to W. Yes, right? For the adiabatic process, if I try to write the expression for the adiabatic process, the heat interaction of the system is equal to 0. The heat interaction of the system is equal to 0. So from the first law of thermodynamics, I can write that delta U plus delta W should be equal to 0. Or I can write that delta U should be equal to minus delta W. And if I talk about the isobaric process, for the isobaric process, again delta Q, it is equal to delta U plus delta W, right? And what is the expression for delta Q for the isobaric process? Anyone can put the answer in the comment box. What should be the expression for delta Q? What should be the expression for the delta Q for the isobaric process? Can anyone put the answer in the comment box? What should be the expression for the delta U? Sorry, delta Q. Okay, no one is commenting. Dear students, delta Q for the isobaric process is NCP delta T. And what is delta U? Delta U is NCV delta T. So delta W, it becomes NR delta T. Yes, NCP delta T. Yes. And if I talk about the isothermal process, in that case, what is the process? If I apply the first law of thermodynamics, which says that delta Q is equal to delta U plus delta W. So delta U is equal to 0. So from here, delta Q is equal to delta W for the isothermal process, right? And what else we are left with? So if I erase this also, if I erase this, I need to. So we discussed two processes. We discussed the isothermal, and we discussed the isobaric. What about isochoric? So isochoric, give me the expression for delta Q for the isochoric process. Isochoric process, give me the expression for the delta Q. So dear students, what is the key feature of isochoric process? That delta W is equal to 0 or volume is going to remain constant. Either delta W you say to be 0 or volume is equal to constant. So if I say that, if I go with the first law of thermodynamics, says that delta Q it is equal to delta U plus delta W. So dear students, if delta W is 0, it means that delta Q it is equal to delta U and it is equal to NCV delta T. So for the isochoric process, delta Q is equal to NCV delta T. Yes, NCV delta T is the expression for the delta Q. So you must be very clear with all the expressions for delta Q, delta U, delta W. So if I try to sum up the discussion that we just did, delta Q for the isobaric process, it is NCP delta T. For the isochoric process, it is NCV delta T, right? And for the adiabatic process, delta Q is 0. And for the isothermal part, delta Q is equal to delta W, right? For the isothermal part, delta Q is equal to delta W. Now, what should be the expression for delta W for the isothermal part? Can anyone give me the expression for work done in the isothermal process? If the state of an ideal gas changes from, see, if I am asking you the expression for the delta W for the isothermal process, the initial state is P initial, V initial, T, it goes to P final, V final, T. So can anyone give me the answer? NCV delta T. No, I am asking you the, okay. I am asking you the work done in the isothermal process. I am not asking you the change in internal energy. Change in internal energy for the isothermal process will be equal to 0. I am asking you the delta W. So the process equation is PV equal to constant and work done it is equal to PdV. So from here I can write that dW it is equal to C by V dV. Now you just need to perform the integration. So from here if I try to integrate, it will become C ln V final by V initial. This is one of the expression for the work done. And if I try to modify this, it can also be written as equal to C ln P initial by P final. Either you use this, So V final by V initial or P initial by P final. Anyone is having any confusion while dealing with the expression for work done for the isothermal process? You can put your doubts or confusion in the comment box. So dear students, these are the two expressions. If I try to modify this C can also be written as nRT. So nRT ln V final by V initial or nRT ln P initial by P final. Anyone having any confusion in this formulas for the, anyone can put your doubts, or you want to study something else, you can put the suggestion in the comment box. We'll cover that topic in the upcoming classes also. Okay, comment box is dry.